welcome back. And so, chapter 3 is finally about, well, yeah, in 3.1, I mean, maybe I'll go back and talk about the toolbox, but in 3.1, we finally get to talk about, we get out of linear functions. We spent 2 chapters, we spent several weeks with linear functions. Now we can talk about quadratic functions. And these quadratic functions look like this. The word is quadratic, but what they look like is something x squared, something x, and then some number maybe. I mean, in general form, that's a quadratic function. It's got the x squared in it. You know, if this term wasn't here, it's a good old, look at it, then it's a good old linear function. You know, so by adding this x squared term, it's a quadratic function. It's not a line, and in fact what it is it's a parabola. Its shape is, these are called parabolas. Parabolas. They look like this. Or they look like this. We say they open up or they open down. We say they open up or they're upside down and they open down. You know, either way. There are parabolas that open sideways. But we're not going to study those. That's not these guys. But there are parabolas that open sideways, but we're not really studying those. Do you know why?
Because they're not functions.
Good, thank you. It fails the vertical line test. It's not a function. Yeah, right. You know, what we may get to eventually is if you cut it in half and ignore his bottom half, that's a function. So half of a sideways parabola is a function. But anyway, we're right at the moment, we're studying what we call up or down parabolas. These are functions, and they all look like this. This A, B, and C are numbers in front of the variables, and the A, B, and C are called coefficients. It seems to me the most important part of this parabola, this quadratic function, is what we call the turning point. When it goes from, oh, here's a funny question. You know, with those lines, they either increased or decreased, I guess. We talked about the slope, whether they, what about this thing? Look at this guy. Does he increase or decrease? And that's kind of a stupid question. Does he increase or decrease? And your answer should be increase. Right, no. See, I'm misleading you with my question. Does he increase or decrease? And the answer is both. When we talk about increase or decrease, we read left to right, and even though I got little arrows that says this is going up, left to right, this is decreasing until it hits this turning point, and then it starts increasing. So it's doing both. That was a tricky question. It's decreasing, then it's increasing. And what it did was it hit this turning point, I called it, or a minimum point. What about this one? Reading left to right, I mean, I know the arrows point down, but reading left to right, it's increasing. It reaches a maximum and then it decreases. And so to me, the most important part about a parabola is these turning points, and the word for them is vertex. But I'd like you to know that in this case, the vertex is the peak of this parabola. It's called the peak, it's called the vertex, it's called the maximum in this case. But on these kind of parabolas, you don't call it a maximum, you call it a minimum, maybe. I mean, both of them are called minimum. Both of them are called vertex. And it's a point, and it's the most important point about the parabola, if you ask me. And the little formula for it is this. The vertex is a point, and here's the formula for it. It's negative b over 2a. That's the x value of the vertex, always. Negative b over 2a. And where do you get your a and your b? From this form. If you're in this form, there's your a, there's your b, there's your c, and that's always the vertex. Now, really, hang on, I shouldn't point to that and call it the vertex. That's half the vertex. That's the x value of the vertex. The y value is this. You know, after you find that x value, you plug it into the function, and that's how you get your y value. By the way, That's what that says right there. It says, after you get this x value, take that x value and plug it in your function, and you get your y value. So, these are good, basic, beginning parabola ideas, but they're super important. I mean, they're the key to the whole chapter, maybe. Well, there's other stuff in this chapter. But quadratic functions is a big chunk of this chapter here. A big chunk of this test in a few weeks. Let me just point out another thing in general there. Just in general, I'm doing this, I'll do a real problem in a second, but this abstract problem here. What if I wanted to find the y-intercept? How do you always find a y-intercept? You guys know. How do you always find a y-intercept? Always. You don't know. Maybe you don't know. I give you too much credit. Maybe you know nothing without me. You know nothing. The y-intercept. How do you always find the y-intercept? Okay, I'll tell you, okay? I'll tell you. You want me to tell you? I'll tell you. If you're a y-intercept, you live on the y-axis. If you live on the y-axis, your x-coordinate is 0. So to find a y-intercept, you let x be 0 and you try to find y. In this general form right here, if you let x be 0, guess what you get?
C.
Thank you, you get C. So you could walk around this world memorizing the fact that that's always the y-intercept. But the truth is, just plugging in a 0 real quick confirms that. So you don't really have to memorize it, but you do have to memorize this. How do you find a y-intercept? You plug in a 0 for x. But you'll get that number. That's the y-intercept. When it's in this form. You know, the parabolas come in other forms. Sometimes, let me just show you something. Another form of a parabola is this. A, and they get it all kind of factored and manipulated into this form. X minus h squared plus k. Again, I'm talking abstractly here for a minute. But they're either in this form, and I've taught you some good ideas, or they come in this form where now you better not tell me k is the y-intercept. You better not. You better, if you want to find the y-intercept, you better plug in a 0 for x and get to work. That's kind of messy. But what's not messy on this one is the vertex. When it's in this form, the vertex is staring right at me, actually. When it's in this form, the vertex is that h, comma, k. It's those numbers, h and k. You know, the book, they present both of these to you. So maybe you kind of need to memorize a couple different formulas, although if you were in this form, do you know how to get it into this form? If you're in this form, do you know how to get it into this form? Maybe you don't, maybe you do, but I would FOIL it all out. If you FOILed it all out, distributed and gathered like terms, it would look like that. So maybe, but you don't have to, because if it's in this form, the vertex is staring right at you. But if you forgot that somehow, you could FOIL all this out, put it in this form if you love this form. Let's do a problem. Oh, wait, hang on, one more little note. The key to whether the parabola opens up or opens down is this leading coefficient a. So if a is greater than 0, when a is positive, the parabola opens up. When a is negative, when that leading coefficient is negative, when a is negative, the parabola opens down. Or it's upside down, or it opens down. So there's a few more little notes. There's some notes. There's a note about a y-intercept, vertex. Depending on which form you're in, you can get the vertex. Either case, that's true about a, though. That letter a, that leading coefficient a, is either positive or negative, and it opens up or down. So that's a lot of quick information in 10 minutes. We got to practice it. Let's practice it. So this is an easy one, but I think I need the vertex. I think I want to sketch a graph. I think I want to do a lot of things here. So I need the vertex. I need step one, I need the vertex. So how do you get the x value of the vertex? It's negative b over 2a. What is b? What is b? 4, thank you. So it's negative 4 over 2 times a. What is a? What is a? What is a? What is a?
1.
A is a 1, right? My a, my b, and my c is negative 5, right? So yeah, negative 4 over 2 times 1. This is negative 4 over 2. This is negative 2. That's not the vertex. That's the x value of the vertex. To find the y value of the vertex, what this says, where is it? I use this little cool formula to get x. After I get x, I plug it in the function to get y. That's what that says. I plug it in the function to get y. So that means I got to take negative 2 and plug it in there. That's negative 2 squared. That's 4 times negative 2. That's minus 5. Yeah, this is good stuff. And as you can already tell, I mean, the work is more work than chapter 1 or 2. And I mean, there's a little more work involved. And you got to square things, and you got to, I don't know. I think it's a tougher chapter. The evidence is that students can make more mistakes in this chapter. So you should practice it, I think. This is a 4 minus negative 4, negative 9, I believe. Cool. Man, I mean, I know so much now. I mean, here's I can sketch a quick graph of this so easy. You ready? Here I go. I'm going to sketch a quick graph of this so easy. Where's the vertex? The vertex is this point. And it is this point, and it is negative 2, comma, negative 9, I guess. If I did that right. That's the vertex. Where is it? Let's find that. Negative 2, negative 9. Okay, right there. There it is. That's the vertex. So that's the minimum or the maximum. I don't know. It depends. Does this parabola open up or does it open down?
Up.
It opens up. How do you know it opens up?
It is a positive.
Because this leading coefficient's positive. It's a positive 1, it opens up. Okay, so it opens up. So guess what? Maybe I should just draw it. Hang on. To get it a little more accurate, I'm not sure how wide or how skinny to make it. Really, I don't want to plot millions of points, as you can tell. I mean, I got my work cut out for me just finding the vertex. But I would like to plot one really easy point, like the y-intercept. In other words, plug a 0 in real quick, and you can get the y-intercept. If you plug a 0 in real quick, by the way, it's just that number, like we sort of said. So it's negative 5. That's the y-intercept, which is where the graph crosses the y-axis. All right, so with that point plotted, the vertex is at negative 2, negative 9, and that point plotted, I'm kind of happy. I have a picture of this parabola. Parabolas are nice and symmetric. So whatever's happening on the left side, the exact mirror image is happening on the right side. And I think I graphed it real quick. I needed the vertex and maybe plotted another important point. I needed 3 things. The vertex, plotting an extra point, and the knowledge of does it open up or open down. Those 3 things, and you got it. The vertex, does it open up or down, and maybe one more point just to get a good graph. One thing students do, or maybe in this chapter, is they get a little confused. There's 2 important y values, I think. I mean, when you're finding the vertex, there's the x value and the y value of the vertex. But then there's this thing I keep saying, well, let's go find the y-intercept. Well, the y-intercept is also a y value, but it's different. And so I think some students get confused. They think that's the y-intercept sometimes. I mean, it's not. It's the y value of the vertex, that's one thing. The y-intercept is usually another thing. Sometimes they might be the same. You might have a parabola, watch this. You might have a parabola whose vertex is right on the y-axis. Look, so there are cases where the y-intercept is the y value of the vertex. But usually they're just different y values. And don't confuse them. So that was cool, man. I just gave you one. Hey, can you guess what's the next kind of hard part of this problem? Well, I mean, the vertex, does it open up and down? The y-intercept. There's something I sort of left out of the discussion. Maybe there is a couple more important points that would help. Maybe these important points, what do you call these?
X-intercept.
X-intercepts. Yeah. We're going to need those. And that's what kind of steps this up a notch too. I mean, to find the x-intercepts, there's a lot more work involved. Well, I think that's kind of up in 3-2, but I may get to it before today's over. But I'll just leave it hanging right now. The one thing we didn't do yet was find any x-intercepts. Let's try this. Y equals negative 3x minus 2 squared plus 8. All right, well, anyway, all of a sudden, bam, boom, I'm in this other form. If you thought this was fun and you appreciate this and you like this, then maybe you want to put this in that form, which means FOIL it all out, put it in that form, and then you can get to work. That's not really my advice. Really, my advice is when it's in a different form, learn how to work with it in a different form. And when it's in this form, one of the beautiful things that's staring right at you is the vertex. That's what I said. When you're in this form, which is the h and the k is the vertex. Notice, though, that it's the opposite sign of that h. You got to watch that in the formula. So it's the opposite sign of that h, but it is the sign of that k. So you got to watch this. In other words, the vertex is 2, 8. That's it. It's staring right at me. I got that memorized. That the vertex is 2, 8. So it's a parabola. Let's find that place. The vertex is 2, 8. If you don't mind. Over 2, up 8. Does this one open up or open down?
Down.
It opens down. Why does he say it opens down? That negative 3. The leading coefficient is negative. By the way, because it's a 3, it's kind of skinny. This is I think this is a little skinnier than this other guy. I think multiplying by a 3 makes it. But let's see what happens. So it opens down. Oh, well, if it opens down, I'm just ready to draw the damn thing. Except I kind of don't know how wide or skinny to make it. I mean, it would be nice to plot some more points. You know, I could plot 1, I could plot 3, I could plot 4, I can pick any x's I want and plot some points. But it is kind of nice to just plug in a 0. Although, plugging in a 0 in this form was real easy. You know, that was real easy. Plugging a 0 in this form takes some work. Let's try it. If I want the y-intercept, I plug in a 0 for x. And that's going to take a little work because it's negative 3, it's 0 minus 2 squared plus 8. So I got a little work to do. It's not the worst thing in the world. Do your order of operations, though. Make sure you square this before you multiply by the 3. So if I square, it's a negative 2 squared. I guess that's 4. And then when you multiply by the negative 3, it's negative 12 plus this 8. Negative 12 plus 8 is negative 4. So the y-intercept is -4. That's me plugging in a 0 for x, trying to find the y-intercept. In this form, it takes a little more work. Cool. Oh shit, so, excuse my language. Remember I said it's kind of skinny? I mean, now that I plotted that y-intercept, I can tell this dude is pretty skinny. Check this out, the y-intercept's way down here at -4. So this has to come down and cross that y-intercept at -4. It spreads as it falls. It's spreading out a little bit, but this guy is a little skinny. I'm going to try to make it symmetric on the other side. Let me step back and admire my work. Oh, wow, that's beautiful. That is admirable, admirable work. I would like, you know, these are rough sketches. If you're doing this for me on a test or a quiz, you know, do your best. Don't be too crazy. Don't be too picky about it. But try to do what I do. I try to show you examples of how to do math. I sketch fairly accurate graphs, but I don't spend hours doing it. Listen, one thing I do get picky about, when you draw a parabola, it does this thing where it does continue to spread out. I mean, that's what it does. And so, you know, like an umbrella or something. Anyway, so don't do this. I see students do this. You draw a quick parabola, and if it starts to bend in, that ain't right. It's not supposed to bend in. So I'm not too picky, but I might get picky about certain things. Cool. Those are two good examples. There's a lot of good word problems. I'm not sure if maybe I'll get to a word problem before I quit today, but let me just preview the word problems. What the word problems are going to ask for, they're going to give you an equation probably, and it might be revenue, it might be profit, it might be something, but they're going to ask, when is it a maximum? Or maybe if it's cost, I mean, if it's profit, you do want it to be a maximum. If it's cost, you want that to be a minimum, actually. So anyway, you might have word problems that ask for maximums and minimums. What are they asking for? What's another word for maximums or minimums? Thank you. Thank you. Thank you, thank you, thank you. Right, right. They won't say that. They won't say find the vertex. The word problem will sound scary. It'll sound weird. It'll say find the maximum or the minimum. The vertex. Find the vertex of the parabola. There may be some subtle things about when you do find the vertex, you know, it does have these two pieces, the x value and the y value. So the x value might be the number of units you build and produce, and the y value might be the profit. You know, these numbers don't make much sense for that. But the x value in the word problem might be the number of things you're building and selling. The y value is probably the dollars, the profit or the revenue or whatever it is that you're maximizing or minimizing. It might not be money, it might not be profit, revenue, and cost. We also, in the physical world, when you throw something in the air, the way gravity works, you ready? Watch. This is probably not the best, but when you throw something in the air, I swear to God, its shape is a parabola. The way gravity works, the way the physical world works, it's a parabola. Maybe it's not perfect if there's little wind resistance, little things like that, but we do kind of, it's a parabola. And so there's a lot of good word problems about throwing something in the air. You threw this thing in the air, what's the maximum height? The maximum height would be the vertex. Yeah, yeah. Okay, cool. So that's a nice introduction to quadratic functions, parabolas. You know, let me step back to the toolbox a second. if I go back to the toolbox, I discovered some of this. So I'm stepping away from parabolas. I'm going to get back to them. One of the things I noticed is they do some stuff with rules of exponents here. So I'm just stepping back and thinking about some rules of exponents. Do you know how to handle a negative exponent? To me, this is sort of intermediate algebra skills, and then they just kind of show up in college algebra. So I don't feel like I'm teaching this. I feel like I'm reminding you of this here in college algebra. Not real sure how this shows up in chapter 3, but an x to a negative power is you move it down, and you call it 5 over x to the third. You can move the whole term down, or this factor down, and change his negative exponent to a positive exponent. Do you know what it means to have something raised to the 0?
It's 1.
Yeah, anything raised to the 0 is a 1. These are kind of funny exponent ideas. Do you know this, I think, that if you multiply things that are like bases, if they're the same base and you multiply these things, you can add the exponents. You probably do that one, x to the 7th. If you have x to the 5th divided by x squared, now you're dividing terms with the same base. You subtract exponents. The answer is x cubed. Here's another one. If you have x squared and you raise it to a power like 3, so now you have an exponent raised to another exponent. The rule is multiply those exponents. Don't add these. Multiply these. So the answer is x to the 6th. I just threw these rules out here like you're supposed to just know them or memorize them. I'm reminding you of some old rules of exponents is what I'm doing. And I did just approach it like they're rules. I didn't do a great job of explaining it. I mean, it's cool to understand what's going on. It's like right here. An x squared is an x times an x. An x to the 5th is an x times an x times an x times an x times an x. So it's obvious that you have 7 little x's multiplied together. I mean, you know what I mean? I mean, it's a rule that you memorize, but it's also cool to get a feel for why it works. I see 7 little x's multiplied together. That's x to the 7th. On this one, I see x to the 5th. I see 5 little x's all multiplied together over a couple x's. So guess what I do? Cancel a couple of x's, leaving me x cubed. It's obvious in a way. What's this? This is an x squared, times an x squared times an x squared. So that's what that is. X squared cubed is x to the 6th. It's important to sort of identify, when you have an exponent, to identify who's the base. When I have this exponent 5, the base is x. When I have this exponent 7, the base is x. What about this one? This has an exponent of 0. What's the base? Because it's in parentheses, the base is the entire 5x is the base. Up here, the 5 is not part of the base. Up here, the exponent is -3 and his base is x. Put parentheses on it, and now the base is the entire 3x. And if you want to square it, you should square everything. You should square the 3 and the x. This is 9x squared is what this is. But now the 9's not part of the base. Now the 9 it's already been squared. Now it's out front. This number, this 3 is not part of this base, right? What's being squared here? The x minus 2. When I plugged in a 0, what's being squared here? Just the -2, or the 0 minus, the negative 2 is being squared, not the 3, right? So that's important. Who's the base? What's the exponent on? And sometimes it's only on, right. You got to think about that. I mean, it's very common for students, they know about this negative exponent, they know to move it down, but they'll move the whole damn thing down, and that's wrong. The 5 shouldn't move, the 5 should stay on top. Right. The 5 shouldn't come with. The 5 is not part of the base. Don't move it down, right? Let's see, I'm looking at this toolbox a little bit. All of a sudden this shows up. This is just, one of the things about the toolbox is a little funny. This stuff shows up out of the blue here. This is called absolute value bars. I think you know that. These little bars mean absolute value. Do you know the absolute value of 3?
3.
Good job. Do you know the absolute value of negative 3?
3.
Yeah, good job. Do you know the absolute value of x? Say no. No. Good. I mean, what do you know about absolute value? That it takes whatever's inside, whether it's positive or negative, and it makes it positive. Maybe that's what you know about absolute value. There's a couple different ways to think about it, but that's one good way to think about it. It takes whatever's inside can be positive or negative, but when you put the absolute value bars on it and take it out, it's got to be positive. So the answer is positive. The answer is positive. When you have a variable x, you're not sure whether it's positive or negative, you guys. You don't know. I mean, I know there's no negative sign, but that ain't the point. It's a variable x. It could be a 2, it could be a negative 2. We don't know what it is. So I probably don't really need to say this, but I'm going to go ahead and answer this question for you. Here's what the absolute value of a variable is. Well, I'll tell you what, it's himself. It's just himself if x is greater than 0. Doesn't that make sense? I mean, if x is positive, what's its absolute value? Himself. If x is a 3, what's his absolute value? 3. If x is a 7, the absolute value is 7. So if x is greater than 0, maybe I'll put equal to or equal to, then the absolute value is just himself. But watch this. What if x is less than 0? What if x is less than 0? What if x is a damn negative 3? Then what's his absolute value? 3. Is that x?
No.
No, that's negative x. And then students look at this and say, dude, you can't have this be negative. This ain't negative. The x is negative. That negative sign is actually making this positive. The x is negative. That extra negative sign is what's making it positive. Because it says if x is negative, you throw that. So the absolute value of a variable gets kind of complicated. All right, let's get back to something else. So then, what about this stuff? We just learned about rules of exponents. We learned about some rules of exponents, and now all of a sudden, I have this x plus 8 squared. I don't think any of this applies, really. Well. Anyway, there's an exponent. And there's a base. What's the base? I told you it's kind of important to identify what the base is. What is the base?
X plus 8.
Thank you, the x plus 8. And if the base is a binomial like that, it's these two separate terms. What you can't do is square each term. What you have to do is you have to go, this is x plus 8 times x plus 8. Again, I think this is algebra you already know, and I'm reminding you of this. But what shows up here is some classic mistakes. I mean, so I'm explaining this to you. So now you have to FOIL this out, right? You guys heard of the word FOIL? I mean, we haven't. I mean, I'm trying to think. It It's already October, but we haven't really done this semester, right? We've been stuck with linear stuff. I haven't been foiling anything. I haven't had squares or cubes or anything. You know, I like to say you multiply everybody by everybody. You multiply the x times the x, you multiply the x times the 8, then you take the 8 times the x and the 8 times the 8. Like I said, I think you multiply everybody times everybody. The word FOIL means you do the firsts, you do the outers, you do the inners, and you do the lasts. That's what FOIL stands for. Firsts, outers, inners, lasts. Whatever. Here we go. You get an x squared. You get an 8x. That's just the first guy. Here comes the 8 times x again. So that's another 8x. And then you get an 8 times 8, which is 64. And so you add up these middle terms, and this is what you get. A typical trinomial. A binomial squared is usually this trinomial, not always. Hey, do you know the classic terrible mistake students make? We just did this correctly. Do you know the classic terrible mistake students make? I think they think like this. Like, see this guy? See this was multiplied, and so if this is, everybody in here needs to be squared. Everybody needs to be squared, and we did. But with these two separate terms, you got to really square the whole thing like we did. What the classic terrible mistake is students just quickly say, "Oh, I'll square him and I'll square him," and they'll get x squared plus 64, and they're wrong. Don't even. You shouldn't even. Don't look at that. It's wrong. You FOIL it all out, and you get that middle term. What is going on here? All I wanted to do was hit pause.